Okay, hello everyone. So welcome you back our lesson. So today's lesson we will focus about how you can inspect the running step of the quantum circuit. This one a lesson for the introduction, the quantum computing and programming. So okay, I hope after you can you master about how you use the quantum composer. So today is how you can inspect step by step for you when you run the kind of piece of code. Okay, this kind of first time you can see this example, the layout. When you have first the example when you create a new file, and when you create a new file, this kind of empty, right? Have nothing there. And over here you can see this the default system has 4 qubit, right? We have 4 qubit, 0, 1, 2, 3. That's total 4 qubit, right? Yeah. And over here you can see this kind of the key skip, the code is generated automatically, and you can see this quantum register have 4 bit, 4 bit. And this one is with 4 qubit, and one the classical channel create. So this is the corresponding the code for the Q skip. This part is actually is a similar level. You can this copy from this one. You can see it's a similar. And we have open KASM version 2. So this kind of version 2, the code is very simple. Actually shorter, shorter than the QSkit, the version. And over here important, you can see it includes about the QSkit, the lib, library, over here. And they only create to the variable, include about the 4 qubit. Okay, so to make sure you make easier the example and design a kind of very simple the function. So you can delete 7 Q keys. You can click there, you can click and click to each circuit, and you can delete it. Click delete. So over here we have a total 4 keys, right? So now you can delete 3, so only 1 left. So here is you can see about the final. After you delete, you can see this one only have 1 circuit, right? Key 0. So now you can drag and drop Hadamard gate. This one you can drag Hadamard gate. You can click and keep the mouse. And after you drag and drop to this spot, you can drop over here. So you can create and drag and drop 4 times. So you can see we have 4 Hadamard gate in the first circuit, right? And after you click there, you finish about drag and drop, you will see our QSkit code in the right side. They will change. You see this register we have change, right, to the 1, only one register, and the value, the value for Hadamard gate. This one you can see about Hadamard gate include 4, insert 4 Hadamard gate to the circuit 0 Q0, right? So now after you want to you create and you want to inspect how step by step the circuit run and the quantum register run. So you can click, or you can turn on this kind of option, inspect. You can move to the right side, and after you move right side, you can see this kind of this kind of option will be turned to the blue, blue or green. So this green, and will be appear about the news button. This called this kind of button the run, and you can click there to run step by step. Okay, let's just look how you click and run it. So step 6, after you yeah, if you see after inspect, and this one the button, you can click there and can show you seven important the value. First is probability. Yeah, probability for for appearing the qubit 1 or 0, and that kind of state, a classical state. And can you can follow about state vector, the attributes or the value, or you can eventually you can see about the Q sphere, how the qubit look in the the block sphere, block sphere. Yes, if you see over here, you can click step by step. Yeah, you can back, forward. Yeah, this forward and this back. You can click and back and see the state for each kind of step, running step. For example, you can click and see if the value go to the 1 Hadamard gate. So the probability. Remember the last lesson we mentioned, if we only have a 1 Hadamard gate, the probabilities to appear 0 or 1, that is this 50%, right? This 50%, or this 1.5, right? Yes, similar to the to state vector. You can see this kind of value. I remember that's the kind of value in amplitude in the classical or the flat flat vector, and you can see the quiz sphere. Yeah, okay, over here direction. You can see this north pole, right? Yeah, the north pole. And go to after you run to the second, to this kind of certain Hadamard gate. Yeah, you can click and you can see the qubit, the value after to the Hadamard gate. You can see the probability for appears 0 become to 100. Yeah, to 100. And so similar to state vector and the Q sphere. So you can see this one is only focused on the north pole and do not have a z spot, right? And do not have a z spot. You can see. Yeah, that is how different between the value. Over here we have 2 Hadamard gate. The first one only have 1, right? Yeah, that is you run step by step to monitor the state. Okay, now you go the value go to 3 Hadamard gate. Yeah, so you can see this go back about 1.5, or this guy at 50%. The probability, yes, probability 50%, and everything is similar to the first case. Yeah, the first case. So after you run the 4 gate, yeah, it's go back. Yes, go back. You can see this 100, right? This 100. This one is 1. Yeah. So you can see actually this case and this case have a same the result. You can see, yeah, right? You can see the same. So Hadamard gate, the value after Hadamard gate, yeah, will affect to the probability and amplitudes or the position in or direction in the Q sphere or block sphere. Yeah. And after you you run the design of circuit, yeah, you can measure the qubit channel, and you can write to the classical. And over here you can see after after run in the 4th Hadamard gate, you can have a result in the Z Pauli Z, okay, Pauli Z state. And this code can show you how to measure the qubit, the state. In the coding. So actually this one can because this one, after you you add drag and drop this measurement, this code can automatic generate by itself. So you do not need to code by yourself. Okay, this code generate automatically generate. Yeah, so that is very convenient. And now you can click step and run to see how you can see the result. Actually, this one you can need to click to the step and run, and important you can select the system and simulator. Over here you can select the IBM QQQ, IBM QQQ or IBM the Jakarta, or some the QKit system near the position. For example, someone's live in Manila or the Jakarta or in Hanoi or Taipei or Tokyo, so you can select the simulator and how many qubits you want to do. So you can select the version over here. Actually, near to you is faster. Okay, that is how I just introduced about how you can inspect some running step for the quantum composer. So I hope this one is very good when you want to debug the program, and you want to see how the workflow goes step by step, and how you can monitor probability for the qubit 0 and qubit 1, and how you can see the change in the Q sphere, the direction. So I hope this one is a kind of very basic but very benefit for you when you want to monitor every step and you want to monitor how the quantum works in practice and understand the workflow. That is called the workflow. Okay, thank you everyone. So see you in the next lesson.